We saw in a previous video what can happen if we try to perform a normal model on data that's skewed, on a population data that's skewed. So that's really what this section is about, is how do I assess the normality of a population's distribution. Now, we're going to let technology assess it for us, but I want to show you what it's going to look like when we are assessing it. So we're going to talk about this normal probability plot, which in StatCrunch for us is going to be called a QQ plot. So this normal probability plot or a normal quantile plot is what we're looking at. And we're going to draw this normal plot, but I want you to notice what the histograms are looking like next to it. So here on the right-hand side of your screen is the normal probability plot. And the distribution here, you'll see this red line that's off to a slant here in the screen. And notice that all those blue dots are lining up pretty nicely along that red line. And to the left over here, you see the histogram representing that data. So when I have my all the dots, let's say, lined up in a row along this red line, then the population's distribution is going to be normal. If I did that same probability plot here, notice that that red line that I am interested in and all those blue dots, that the blue dots are kind of snaking around that red line, if you will. And this type of distribution is indicative of some sort of uniform distribution, which you can see from the histogram on the left. Finally, we have that skewed distribution. So here I have that red line, and you'll notice that those blue dots, they don't really come close to lying on the line at all. And the distribution, the histogram representing that data on the left, is showing an obvious skewed data set. So we're going to use this idea to be able to assess the normalcy of our population data if I don't know whether or not the sample came from a population that was skewed. So in order to assess the normalcy using our technology, we're going to do two things. First, we're going to use StatCrunch, and in StatCrunch, we will be using the QQ plot, which I will show you how to do. But also, we're going to add the correlation coefficient to be able to determine that as well. So we spoke previously that the letter R is our correlation coefficient, and we're going to evaluate it with the critical values associated with that particular data set. If R is less than the critical values that come from a table, we are going to make the conclusion that it's not a normal, it does not come from a normal distribution, and therefore you would not want to apply normal models to it. So let's see what something like that looks like in this example. Here I have a random sample of 25 years between 1890 and 2011 for the amount of snowfall in inches for Memphis. And we want to use that normal probability plot and technology to be able to determine whether this sample data could have come from a population that's normally distributed. So here's the raw data on your screen that you see, and we're going to switch now into StatCrunch. So we'll get rid of our calculator, we don't need that anymore. In this column for snowfall is the information that we're interested in, and we're going to go to graph, scroll all the way down here to what's called QQ plot. We're looking at the snowfall column, and we want to add that correlation statistic. So that's really all we have to do here in StatCrunch, except hit the compute button down at the bottom. And you'll notice that just by looking at the QQ plot, I can see that these blue dots don't lie up anywhere close to that red line, and so I'm making the assumption just based on that it's not normal. But we can also make that conclusion based on this correlation statistic that we had added to the graph. So this is R, and it's equal to 0.877. So let's go back to what we were looking at. When R for our data is equal to 0.877. We're going to evaluate that with the table with a critical value that comes from a table that you need to be given. Remember, to use this table, we need to determine our sample size, which was 25. So if my sample size is 25, I find 25 on the table, and I follow it over to the critical value associated with that sample size, which is 0.959, which is our critical value. And it's pretty clear to see that R is less than the critical value, so our conclusion is that this does not come from a normal population. We could have seen that just based on the QQ plot, but this is another way for us to identify that it doesn't come from a normally distributed population, and therefore we wouldn't want to apply a normal model to it as it is.